In the last task, only one partition was created. In this task, we shall create 4 partitions and format each one, then delete them to see the relationship between each partition and how this can influence, if any, the drive letters. We shall also discover partitions that we need to be made aware of. A second hard drive is connected as it were in the previous task, or use VirtualBox with an additional drive. First, let's check out this PC. As expected, the new hard drive does not appear. Now let's start Disk Manager. So here we have our 3 drives, Disk 0 or C drive, the new hard drive that has no partitions, and the CD-ROM drive. We shall now create a single partition, roughly 25% of the total hard drive. We select the disk first, then click on Action, All Tasks, then New Simple Volume. Click on Next when the wizard starts. 25% of the hard drive in our example is 125 gigabytes, but notice the volume size is in megabytes. So we enter 125,000 megabytes. Then Next. Here we have the opportunity to change the drive letter. We shall leave this and click on Next. This time we shall format the partition. Leave these settings and check that Perform a Quick Format has been selected. Here you will find a summary of the new simple volume. Click on Finish to complete the partition. After the formatting has been completed, a window called New Partition E. As expected, it contains no data. We shall create a folder called Partition 01 on this newly created partition. Then close it. Before continuing, we will examine the DMC. The first thing we should notice is that 25% of the total hard drive space has been allocated to a new volume, named E. Next, 75% of the drive is unallocated and cannot currently be accessed. In the top section of the DMC, a new volume has been created. The layout is simple, the type is basic, and the file system used is NTFS. At this point, we should only be concerned with the fact that we can use the unallocated space on the hard drive to create a partition. We return to formatting and file systems a little later. We shall create 2 further partitions, the same size as the first, format them, and create a folder on each one. So we select the disks that we want to create the next partition on. Action, the New Simple Volume. Next, when the wizard starts, click within the box to the right of Simple Volume in megabytes and change this to 125,000. Do not change the drive letter. Check that Perform a Quick Format has been selected, then click on Next. Click on Finish. Create a new folder called Partition 02. Let's just check this PC again to see the effects of these 2 partitions. As expected, we now have 2 volumes named E and F. And if we return to the DMC, we should find a second blue bar labelled New Volume F. Now a third partition. Same size as the other 2. When prompted to assign a drive letter or path, click on the selector to the right of drive letter, and we can see here we have an option to change this to any other letter but those that have already been used. This means that no 2 drive letters can be the same. Select the drive letter E. And create a new folder called Partition 03. At this point we have created 3 partitions. Each one has been formatted and they all contain a folder which represents our data. Also, they are called primary partitions and known as basic disks. But what will be the effect if one of these partitions is reformatted? Does this affect the data on the other partitions? We can check this by formatting new volume F. We now have the opportunity to configure how to format the hard drive. Click on the selector to the right of File System and this should cause a drop-down menu to appear. In previous versions of Windows, it was possible to format the partitions using FAT32. However, Windows 8 only supports NTFS. The main advantage of NTFS is the security it offers over FAT32. There is also an option for the allocation units. Click on the selector to the right of this and we can see the many options. In the task that covered defrag, these sectors were briefly explained. Here we can choose a size. Choose default. It is also possible to change the volume label. Here we have given it the name George. Click on OK to format. Notice in the top middle of the DMC drive F has now the label George. An important point here is that we can change the volume label and this can be useful for identifying partitions in a computer system. For instance, there may be many users that are sharing the same drive, so it is possible to rename a volume label as a user's name. Or one partition may be used for storing data, and from time to time this partition is backed up, so it would be appropriate to call that partition data. But has the formatting affected the other partitions? Once again, let's check this PC. First, local disk E. Here we should find the original folder called Partition 01. We now click on back, then double click on George F. As expected, the folder has been removed since this has been formatted. Now we shall check volume G, and once again the data has not been affected. We can conclude from this that formatting one partition does not affect any other partition. So what effect does deleting a partition have on other partitions? Let's delete the partition called George. It is selected, then from Action, All Tasks, Delete Volume. Now let's check this PC. Notice the drive letters have remained the same. It is possible to change the drive letter G to F, but if there is an application that relies on drive letters, then this could cause it to malfunction. A typical example would be a backup utility, which saves data to a specific location or drive letters within the computer. If the drive letter is changed, then the utility may not be able to find the original location. Notice that we have 2 unallocated spaces now. One thing we should be clear is that DMC is a virtual control panel. Although we see here 2 partitions separated by some unallocated space, strictly speaking, this is not true. The way the partitions are created is far more complicated than the representation that we can see here in the DMC, and one that is beyond the scope of this course. Our only concern is how to use the DMC to manipulate partitions. Would it be possible to use both unallocated spaces to create just one partition? Let's try it. So we select the first unallocated space on disk 1. In our example, the maximum disk space in megabytes is 124,999 megabytes, or about 125 gigabytes. We can see unallocated space of 133.79 gigabytes. Let's add about 50 gigabytes to the existing partition. So in our example, we've changed this to approximately 275 gigabytes, or 175,000 megabytes. Look what's happened. The next button has been greyed out since we have exceeded the maximum disk space in megabytes. In other words, we can reduce the size of this partition, but we cannot increase it beyond the initial size of 125 GB. Let's change this back to the maximum disk space. In our example, it is 124,999 MB. Recreate the folder and change the name to Partition02. We have two problems creating primary partitions. The first is what we can see here. We could have a hard drive that has 3 partitions and some allocated space, as in our example. The problem with basic or primary partitions is once they have been defined, they are difficult to expand without specialized software. As an example, we may want to take 50 GB and add this to partition E, as we tried earlier. Our only option now is to create a further partition using the unallocated space. Alternatively, delete the new volume F partition and G and recreate them, but as we have seen, doing this will erase any saved data on both partitions. There are more complications. At the start of this task, we said we would create 4 partitions. Let's see what happens when we do. We shall select unallocated space, then Action, All Tasks, then New Simple Volumes. Leave the amount of space in megabytes to the total volume size. In our example, 36,997 megabytes, which is the maximum available space. And create a folder called Partition04. Look what's happened to the last partition. It is graphically different to the others. Before we find out why, let's check out this PC. We can see here there are 4 partitions on the additional hard drive. Once again, a user would be unaware which of these are primary or not a primary partition. The new volume H has a green border. If we check the color code, it is described as an extended partition, but it has a light blue bar which indicates a logical drive. The next task deals with these new partitions, extended and logical. One reason we use primary partitions is to enable a computer to boot into an operating system. Primary partitions contain a special code that needs executing before a system can boot.